In today's video, I'm going to show you how to go from an idea to a package published on PyPI. Along the way, we'll develop our prototype, add version control with GitHub, introduce automated code standards, add tests with PyTest, set up automated checks with GitHub Actions, and finally publish our package on PyPI. There's a lot for us to get through, so let's get started. Now where we're going to start is on PyPI itself, because one of the most important things about creating a package is the name itself. So we need to find a name that hasn't already been taken. Now I've got a couple names in mind, and I'm not sure which one will be available, so let's go down the line. This is going to be a small configuration manager project. So let's try something like miniconf. We hit search, and unfortunately it looks like miniconf is already taken. We see miniconf and it's currently version 1.2.0, even worse. It also looks like this project has been largely abandoned. So while it is possible for us to try to go through the process of claiming the package name ourselves, one big downside is it already has a version 1.2 in the system. And as of the time of this recording, once something has a particular version in there, you can't publish a version lower than that. So even if we were to claim the miniconf title, we'd have to start with at least 1.2.1. And that's not really where I want to start a brand new project. So let's try another name. Instead of miniconf, let's try nanoconf. And look at that, 0 projects for nanoconf. So that's going to be our name. Awesome. And now that we have a name, let's switch over to our editor. And now what we're going to do is we're going to create a new folder called nanoconf, and we'll open that. And this is where pretty much everything for our new project is going to live. Now, the first thing we want to do before we start creating a bunch of directory structure, supporting files, etc., is to create our prototype or proof of concept. So let's do that now. I'm not going to spend a bunch of time on this specific prototype because it's not really going to apply to your particular project. Luckily for me, this is a concept I've been playing around with for a couple of years. So I'm largely going to write it out and bring you back when I'm done. Okay, I'll just give a quick overview of the functionality here. Again, don't want to spend too much time on this implementation, as that's not really the subject of this video. If you want a more in-depth breakdown on how everything in here works, because there are some complex elements to this, then please let me know in the comments, and I can absolutely do a video on that. Okay, first things first, we did have a couple of non-standard imports here, meaning not coming from the standard library, and that is going to be box and YAML. So in order for this to work, I need to pip install them first. But since we're installing third-party packages, it's best to work within a virtual environment. So let's go ahead and create one now. While typically I would use a switch bash function to handle virtual environment creation for me, we'll be a bit more clear for this video and just create everything manually. So python-m, we're going to manually call the venv or virtual environment module, and give it a name, venv nanoconf. I like to stick to a similar naming convention where it's venv and then the name of whatever folder that I'm in. So we'll create that now. VS Code asks if we want to switch to that virtual environment, so we will do that. And now to activate it, we're going to pass in the path to our new virtual environment, its bin directory, and then the activate script. So we run this, and it takes care of some things under the hood. If you have more questions about virtual environments, please check out the video. Should be linked in the top right now. At this point, we are in a new virtual environment. The very first things I like to do is upgrade pip, as well as install IPython. Let's do that now. Okay, perfect. All that's up to date. Let's go install our third-party dependencies, which are Python box and PyYAML. Let's do a quick overview of the nanoconf class itself. In the init, we're just going to accept a config path. So this will be pointing to either a directory containing files or a file itself. We're going to store a couple things like the path itself and the name. And then if it's a directory, we're going to glob for the specific pattern. So for this project, nanoconf, we're going to use a .nconf extension. This way we can have users quickly distinguish between what are nanoconf config files, which will be YAML formatted, and other YAML files that are just in their directory. This way we don't have any kind of complicated config that needs to happen. It's just use the .nconf extension and nanoconf will find it if you're pointing to that directory. So for each of those files that it finds, it's going to create a new nanoconf object and then inject that object as an attribute into the main one. If it's just a normal file and has the correct suffix, then it's going to run our internal load config and our pull envars methods. For load config, we're going to pass in the text from our config file to yaml.load, and we're going to use the safe loader here. Now, one neat thing about this is it allows us to do sub imports. So a user can specify additional files or additional directories. And the way we're going to handle that is create a new nanoconf object for each of those sub imports specified in the config file. I'll show you what this looks like later. And we'll do the same thing here, add those as attributes, as well as load any actual values from the file into box objects, which gives us nice attribute lookup on dictionaries. And then for pull envars, we're going to see if anyone specified an envar prefix in their config file. We're going to go through all the environment variables that are set at runtime and see if they start with that prefix. If so, we're going to strip the prefix out of the name. We're going to try to load something with JSON in case we're trying to pass complex data structures in there. If so, we'll load that value into box. And at the end, we're going to add that value into our attributes using the key name. At the very end here, we have fairly complex repr statement, which will show us the attributes associated at the level that we're in. Okay, now the next thing we need to do for our proof of concept is to do some manual testing with it. First thing I like to do is, if it's a class that I can just initialize, then I'll just try to do a blank init on it. And actually I need to load the file here. No immediate warnings, which is good. So we'll say nc is equal to nanoconf. We'll not pass anything in. And right away we get an error because we are passing none into the path instead of some type of string or path-like object. So what we can do is, instead of having none here, we'll just set dot as our current directory, reload this, and try again. Okay, so now we have a nanoconf object, which has nothing in it, of course. Perfect. So let's create some test config files that we can try loading and see what happens with them. We'll save this one just as simple.nconf. We'll give it an envar prefix of simple, meaning if we want to load additional values in here or override things, we can just create an environment variable that starts with simple and then whatever the field is going to be. So I'll just put some quick stuff in here. Okay, so now we have a simple file. Let's try passing that to nanoconf. Okay, no immediate warnings here, which is good. Let's look at the nanoconf object. Okay, that's good. We see that it did load the simple file, and we have key, test, overridden, and things here as attributes corresponding to each of these here. So if we look at nc.key, we get value. nc.test, we have 1. Overridden is false, and nc.things should be a little bit different. We have a box list. Everything's working exactly as we're expecting it to. Now let's try doing an environment variable real quick. One way that you can do this on the command line for Unix style systems is to just put it in front of whatever command you're trying to run. So we'll say simple overridden equals changed. And then we'll have ipython nanoconf.py. And if we create that instance of nanoconf, we should see nc.overridden is equal to changed. Beautiful. Okay, so our simple example is working exactly as we expect. Let's try giving a more complex example. For this file, we'll call it nested.nconf. And we'll just have some simple stuff in here. Test value again. Then let's do some nesting of dictionaries. This way we can prove that we can arbitrarily nest our data structures. And speaking of arbitrarily nesting, let's also add an import here as well. And we'll say that there's going to be an animals directory. Let's actually make that now. And in that animals directory, we'll create some basic animals like dog. Also throw in an elephant, lion, of course a panda, and the last one we'll say a penguin. So I'll populate these with a quick jump cut and bring you back in when I'm done. And here we are. So I've populated each of these files with some basic information about each animal, and these are going to be largely common between each of the files, so we have consistency with them. The only thing that's different is something I want to test out later, which is an envar prefix for dog itself. Because if I'm right about the current design, we should be able to override and add additional values by environment variable on a per file basis. It doesn't have to be on a per project basis. This should really help when it comes to nested override. So let's go ahead and load this into IPython. Create a new instance of the nanoconf class. This time we're going to pass in nested.enconf. We don't have any meaty errors, which is good. We take a look at this. We have the top level we're expecting. Notice how animals actually corresponds to the animals directory itself. That's really nice. Let's take a quick look at the other two attributes real quick. nc.test, pretty simple, just value. We have top, which corresponds to a box dictionary, which means we can do attribute lookup all the way down. So middle.lowest gives us that final box layer, which means we can go all the way down to that very lowest layer and get v3 from it using all attribute or dotted notation. Beautiful. Okay, now let's look at this animals attribute. And that gives us another nanoconf object. Awesome, and it shows each of the files that we have under there as attributes. So let's take a look under nanoconf.animals.panda, and we see the attributes there. Another nanoconf object, so we can also access its habitat, which says temperate forest of China. Okay, awesome. So at this point, I'm pretty confident saying that our prototype is working as expected, or at least expected enough to move on to the next step, which is going to be creating a Git repository. So here I am on my GitHub dashboard, and we're going to go in the top right here and say new repository. And what we're going to name this is nanoconf, which is also the same name of the directory that we're in locally. I'll just put in a quick description and call it the tiny, opinionated, and easy to use configuration library for Python. We'll make this public. If you want to develop something in private, that's always an option, but I highly recommend that unless it's something you're going to patent, that you develop as much as possible in a truly open source manner. I'll add a README file to this myself later, and I'll also create a git ignore with you in just a few minutes. Now, for a license, this is another contentious subject. It gives you a number of options here initially. I'm actually not going to choose any of them right now. I've got some different opinions around open source licensing, but the top three here are some of the most popular. One of the more permissive of these is the MIT license. So if you don't have any strong opinions about licensing, you might want to select that. I'll go ahead and create the repository now. And some really nice stuff is that when you enter this screen, it gives you a bunch of information about how to set this up locally. So let's switch to that local setup and create our Git repository. Let's initialize our Git repository locally by running git init, give ourselves some room, and immediately we want to add a remote. A remote is basically a reference to a repository that's outside of your local system. The command will be git remote add, then the name of the remote, which will be origin, and then the git URL of that remote. So all together, git remote add origin, pointing to my GitHub repository, which is my name /nanoconf.git. And we can look at our existing remotes by running git remote-v. Right now we just have origin. So some naming conventions we commonly see are origin and upstream. If you're the one that owns the main repository, origin will be your version of that repository. However, if it's a larger project that belongs to someone else or some other organization, then your origin is going to be your fork of that repository. And you'd likely have an upstream remote pointing to that main version of the repository. Okay, so now that we've initialized the repository, let's check our git status to see what it wants to add. Right now we have a number of untracked files here, which is a great time to start setting up our repository structure, because we don't want this animals file here. We don't want nanoconf or any of these to be in our base directory. So let's create a few new directories to organize things a little bit better. We'll start with a nanoconf directory. This is where we're actually going to hold the source code for the project itself. And we'll move nanoconf.py into that nanoconf directory. Now, the animals directory, the nested and simple nconf files, they'd be great things to use for test data. So when we start writing our test, we can use these as the basis for things that we're going to load. Let's make a new test directory, as well as a test/data directory. I'll move all of our nconf files into test/data. And we'll also move the animals directory into test/data as well. Awesome. So let's close some of these things in the top here because the references are now old, and we already have a better repository structure. Source code living under nanoconf.py, then we have our test data directory. So let's keep our nanoconf.py file open. And in order to make this nanoconf directory a module that we can load things into, we'll need to create a dunder init file for that. And I clearly forgot which version of VS Code I'm running, which isn't the insider's build. It is actually just the main build. So we'll create this dunder init.py. Now, we could just leave it as is. However, people wanting to use our nanoconf project would need to follow this import statement to get the nanoconf class. From nanoconf.nanoconf import nanoconf. Obviously, that's pretty ugly. That's because this nanoconf corresponds to this base directory. Then we have the nanoconf.py file itself, which is here. And then inside of that file is the nanoconf class. Putting this under dunder init means that people can just import it this way. From nanoconf import nanoconf, which looks a lot better. Another thing we can do here is we can specify aliases. So if we really wanted to shorten it, we could alias nanoconf as NC. This gives people the option to either import from nanoconf import nanoconf, or they can simply just import NC. It just gives them another option if they want to shorten things. Okay, let's give ourselves a little bit more room and check our git status now. Okay, that looks significantly cleaner. However, we're starting to see some things that we don't want to track. We do not want to track our virtual environments, which is a good time to add a .gitignore file. And in this .gitignore, we can either directly list files, directories, or different types of patterns that we want to tell Git not to track. So for this, we're going to say venv star, meaning ignore everything that starts with venv, which should match this nanoconf virtual environment. If we check our git status now, that should drop off, and we now have a .gitignore file. Okay, so we'll git add and then a dot to add everything that's currently under this repository, and then check our git status. And now we see all the new files that have been added in. We have, of course, our gitignore, our actual source files underneath the nanoconf directory, and then we have our test data. Of course, we don't have an actual test now, but that's something that we'll add in later. At this point, we could create our first commit and push it up, but I want to do a few more things before we move there. One of those things is I want us to be able to pip install this locally. In order to do that, we're going to add a new file. And that's going to be pyproject.toml. So this file is a great newer alternative to other ways that we may have specified some of our project metadata and config settings in the past in their separate files. But this allows us to put it all in a single place, which in my opinion is a bit better for organization purposes. If you're not familiar with TOML files, it's pretty similar to any type files, but you'll get a hang of the syntax as we go along. The main part of this is we break things down into different sections. So our first section that we're going to define is a project section. And for this, we're going to add different types of metadata in here. So it's going to be pretty similar to what looks like normal assignment expressions. Here we're going to say name is equal to nanoconf. We'll also put in our description and a few other fields. Okay, I have the initial metadata in place now. We're mainly specifying things like what the README file is going to look like, which I'll add later. The Python versions that it supports, we're going to say greater than equal to 3.11. This is part of the opinionated parts of this, is I don't want it to be supporting significantly older versions of Python. The license, which I'll add my license file here in a second, a little bit of a different one than what you're likely used to seeing if you're used to seeing open source licenses. And then some interesting keywords that we can add in for PyPI to help the project be a little bit more discoverable. After that, we have a list of authors, currently just myself, and then some classifiers. So these are things that PyPI itself is looking for. As for license, we'll go ahead and actually just get rid of that and see if it'll work without specifying a license, because we're going to use a custom one, like I said. Actually, let's just go ahead and add that now. There we go. There's our open source license. Let's see if we can get away with it. Back to the PyProject.toml. One really important section here is listing the project dependencies itself. Of course, it would help if I were to spell things correctly. That should be python-box for our box dependency, as well as PyYAML. These are two third-party dependencies for the main project itself. And then one thing that we're really going to use later is dynamic versioning. And we're going to use setup tools SCM to do source control based versioning, which in my opinion is the best way to handle not only the versioning itself, but also gives us a really good way to push new versions up to PyPI. So this is the basic metadata, but there's a few more things we can also add in here. Like project.optional, we can specify the repository URL. And then we can add additional sections for things like the build system. So when we go to pip install this, pip will look under this section, among others, and see exactly how we want to build the project itself. So for the build, we want it to have setup tools SCM with its toml dependencies. This way it can read pyproject.toml, as well as wheel. And we'll specify the build backend to be setup tools.build meta. Now there are additional configuration options for setup tools itself, and we can specify that additional configuration in this file by creating a new section here called tool.setuptool. This way we can put in things that are specific to setup tools, and setup tools itself knows to look into the pyproject.toml file and look for this section to pull additional settings from. Now this next section here is really important. This is where we tell it where to look for specific packages. And our package is under the nanoconf directory. So we're going to say include this nanoconf directory when you're looking for packages to build, and just that nanoconf directory. For setup tools SCM, you really just need to include the section here, because this is the same as use SCM version is equal to true in the old setup.py file. So setup.py is the way that we used to specify for pretty much every project a lot of the metadata that you see above. However, everything now is moving under pyproject.toml. So at this point, I believe we have everything in place in our pyproject.toml to start building our project locally. Let's clear out terminal and run pip install, and then a dot to say pip install from the current directory. And what that should do is look in here for compatible files to build on. Since we don't have a setup.py file, it should look in our pyproject.toml and perform the installation. And it looked like it failed. Let's see. Shouldn't contain optional property. That's right. This should be actually URLs. So project.urls instead of project.optional. Okay, let's clear this and try to install again. All right, so that looks good. In theory, if I were to run a pip list right now, we should be able to go up and see, yep, nanoconf is equal to version 0.1.dev. Then it gives us a little bit of hashing on the end. At this point, we should now have our project installed locally, which means we can say from nanoconf import nc, and we have our nanoconf class. Awesome. So at this point, we have a local version of our package, but we're not going to stop there because we're not ready to publish yet. The next thing that we want to do is make sure we have some type of code standards for our project. And even though this is a pretty small project in itself, yours is likely going to be significantly larger than this, especially because I'm sure that the idea that you have in mind is significantly more complex than this. Because even though nanoconf has a number of features that it exposes, this is still only written in 45 lines of actual code. But with this, I can already see some things that I'd like to be better, like this import block here. For our code standards, we're going to introduce two tools. That is black for our actual code formatting itself, and then we're also going to use a tool called rough for our linting. And conveniently enough, we can actually add the config and everything for them in our PyProject.toml file. So we'll create a new section called project.optionaldependencies. And in here, we can create different types of dependency groups. I like what we saw before with setuptools-scm, specifying the toml group. We can do the same thing for our project. So people just using nanoconf don't necessarily need to have these dependencies installed, but if someone were to want to do some development on nanoconf locally, we can create a new dev group. And in here, we're going to specify our development packages. That's going to be black and rough initially. So what this means is that right now, if we look at pip list, we don't have black installed and we don't have rough installed. But if we were to pip install -u, just for good measure, upgrade, again, still adopt because it's local, and then dev for the dev set of optional dependencies, we hit enter, it should install both black and rough. Okay, we see it installed black. Looks like it also installed some additional dependencies for those two. And we also have rough. So again, we look at pip list. We should now see, yep, rough as well as black. Now, what I'm going to do for each of these is copy in some code standards that I already have in mind for both of these tools. So we'll create a new section called tool.black, which will be the configuration options for black. And these are the configuration options that I have in mind for it. So we're going to set the line length to be a max of 100 characters, target version being Python 3.11. Then we're going to set some include and exclude file patterns. Now, rough has a lot of different configuration options available, and we're definitely not going to go through all of them today. So I'm going to paste in the config options I have and explain things briefly. So under rough, same thing with target version, Py 3.11. Rough has the nice ability to be able to fix a subset of its roles. And speaking of roles, here are the roles that we're going to be selecting. Some of these are entire categories, and some of these are specific roles themselves. Rough site has a long list of all the different roles that it can go through, and some of these choices are likely going to be deeply personal. But in my opinion, these are a good set of initial rules to go for, as well as some things that we're going to be ignoring. There's some additional things that we can also do, like configuring different things for PyTest later on, sorting imports, which we'll see take effect here shortly, as well as any specific ignoring and setting McCabe complexity. Now, we don't necessarily have to run these tools for ourselves manually. And the way we're going to do this is by introducing a .precommit-config.yaml file. And I'm going to paste in some config that I already have from another project because this really isn't exciting to type out. Under here, we're going to specify the different checks that we want pre-commit to run by the repo themselves. So this is going to be black from the Python Software Foundation organization. Rev is the version of it or the revision of it. Then we have the hooks themselves. So for black, it's pretty simple. It's just running black. Rough is going to be from Astral SH, and that's going to be the rough pre-commit repository. We see the revision that's available there. And then the hook is running rough, we want it to try to fix things if at all possible. This way, if there's something that it can change, automatically it will do so and make the modification to the file when we run pre-commit. And then if there's something that it can't fix automatically that it has identified as a problem, it will give a non-zero return code when it exits, letting pre-commit know that something went wrong. But now that we've added this additional standard to our repository, that means that for developers, they also need to have pre-commit installed. So we'll add that as a optional dependency under the dev section. Okay, cool. So if we pip install again, dev, we should now have pre-commit installed. And the way that pre-commit works is it'll run in any of these staged files here. So if we were to run this now, we would just run pre-commit. It will install the dependencies that it needs, and we're likely going to see some changes made by both Black and Rough, since this is our first time running it on these files. And here we go. We see that Black reformatted nanoconf.py, and it looks like Rough also fixed one issue, and it found an additional issue in nanoconf.py, specifically on line 39 here, where we're overriding val. Now, this is the behavior that I want to keep, so we can disable this rule by saying no QA, and then the rule itself, ELW 2901. So if we save that and add nanoconf/nanoconf.py, rerun pre-commit, both Black and Rough now pass. So we've done a number of things since the last time we've added things into Git. And we see some good things in here that we want to keep and some things that we want to ignore. So let's go ahead and edit this git ignore to add a few more things in here, like the build directory, anything.egg-info, as well as PyCache directory. Let's check our status again, and that looks better. Now we see we've modified our git ignore, and these three are files that we want to track. Awesome. That allows us to run git add and pre-commit again. So far, we're doing a great job with adding code standards and check to our project. And while we have some test data available, we're not actually running any tests. Let's remedy that by creating our very first test file. And since this is such a small project, it's likely going to be our only file for test. Of course, since we're testing nanoconf, we want to import the nanoconf class. And to make it a bit more succinct, I'm just going to use the NC alias here. Now for our test runner, we have two main options for Python. We have Python's built-in unit test module, or we have the third-party, and in my opinion, significantly better PyTest library, which I use for all of the projects that I'm involved in. At this point, while we're writing our test, it's a good time to split our layout a bit more. This way, we can have our test data on the right to reference when we're writing our test. Because the first thing we're going to test is test simple. And the way we'll do this is we'll say nconf is equal to nc, and we're going to pass in our relative path to simple.nconf. At this point, our nconf object should have loaded all the values in here. So let's make some basic assertions. Our first two assertions here, just make sure that we load in our private name and private envar prefix correctly. And we can also do some assertions on the content. We now have a very basic test in place. But since we're using PyTest, we're imposing a new development requirement on our project's developers, which means we go back to our pyproject.toml, and after pre-commit, we'll add PyTest. Okay, so we'll pip install again, pip install dev, and we can either run PyTest locally, like this. We see that we have a single test and it passed, or we can also set up our test configuration in VS Code, pointing to our test directory there. And this performs a bit better test viewing and running, allowing us to just run the test in our editor itself and start tracking test runs. Let's jump back into our pyproject.toml. And just like we did with Black and Rough, we'll add a new section for PyTest. Specifically, we're going to set its ini options, or its initialization options. And this is just going to set some defaults in here, like the test path being the test directory, as well as some options in here that we don't have to specify at the command line each time. So instead of running PyTest and then the test directory, we should now be able to just run PyTest. It knows exactly where to look, and it also gives us things like its verbose output. Not too bad. But going back to this test, I think it's a great start, but there's some things that we're not really handling in here. Remember how we set the envar prefix for this? Well, I want us to be able to test that environment variable as well. So in order to do this, we're going to import PyTest, and we're going to create a new fixture using the pytest.fixture decorator. Now we're only going to touch the surface of fixtures in this video. If you want me to get more in detail about fixtures and PyTest in general, please let me know in the comments, and we'll likely have to do an entire series of videos on PyTest itself, and potentially even multiple for fixtures in general. Because what I'm going to define now is a bit more of a complex fixture. I'm also going to need to import OS here, because this fixture is going to be called set envars. And that's going to take a PyTest request object fixture, which allows us to pull some information from, in this case, the test that's going to be requesting this fixture. So let me go ahead and write this out, and I'll bring you back once I'm done. Okay, the set envars fixture has now been defined. Effectively, what this is doing is it's going to set key value pairs for a list of environment variables and their values that are passed indirectly to this fixture. It's then going to yield, allowing the test to run. And when the test is finished, it's going to revert the change that it did. What this means is that for this test, we can use PyTest parameterization to set specific environment variables just for the scope of the test. And this is what that looks like. Okay, so I know there's a lot to this line, and if you're not used to PyTest parameterization, this definitely looks a bit daunting. Don't worry too much about that right now. Effectively, what this is doing is it's passing this key value pair, where will be an environment variable, simple overridden with a value of true, to the set envars fixture. So before this test runs, it's going to set simple overridden is equal to true, similar to what we did on the command line earlier when we're setting environment variable before we ran IPython for the scope of this test. And finally, within the test call signature, we need to add that set envars argument. Okay, now that we have that set, we can add a final assertion, and that should be enconf.overridden is equal to the string true. Of course, it helps if you make that not an assignment. Now, if we run PyTest again, we have a passing test. Okay, I have a few more tests to write, which are going to be similar to what we see here, but we're really going to be using a lot of this nested data that we had before with our animals. So I'll go ahead and do that now and bring you back when I'm done. Okay, now I have a few more tests here. We have our JSON envar test, meaning passing in JSON data through environment variable. We also have our nested test here, testing our nested configuration, which also imports our animals here. See how we're checking our panda's diet, as well as a callback to our dog settings file with its envar prefix of test dog, proving that we can set file specific overrides for specific values. Here we're overriding diet from omnivore to just traits. And if we run these tests, we see that all four pass correctly. Awesome. We now have working tests for our project, which is great for ensuring that any changes that you make to your project aren't going to break the functionality that you're expecting. Okay, we've made a few changes now, so let's check our git status. And here you see we have another directory that we want to add to our git ignore. So let's do that now. Check our status again, and these all look good to add in. There's probably something that Rough or Black is going to say about test nanoconf.py. So let's see what they do when we run pre-commit. Okay, and Rough has identified a couple of rules that it doesn't like that we've violated. S101, which is the use of assert, and PLR 2004, which are these magic comparisons. Now, both of these I don't want to apply to this particular file because in the instance of these tests, they actually make sense. What we'll do is we'll revisit our pyproject.toml and we'll add what are known as per file ignores. This can be tool.rough.per file ignores. And here we're going to specify the file and then a list of rules. It's going to be S101 and PLR 2004. Let's check our git status. Since there are modifications to each of these, We'll run git add again, and then pre-commit one more time. And it looks like I actually forgot that I added this section down lower. So let's go ahead and find that and delete this section. And now we've passed pre-commit. Now we're pretty close to being able to push this back up to GitHub, but there's two more things that I want to do before we do that. One is to add a README file. READMEs are great for GitHub because they're effectively the landing page for your project. So you can give people an idea of what exactly your project is. Additionally, your README is what PyPI is going to display on your project's page. So they're pretty important for getting users to actually want to use your project itself because you can explain what it is and how to use it. Now, since this README is going to be decently long, I'm going to do another cut and come back when I have the contents of the README fleshed out. Okay, so the README has been written out. I break it down into sections for the project description, how to install it, then some usage information, initially just some basic usage information, and then we break down things around configuration file formats, some project directory structure for how they can store the files, as well as information about using environment variables. So all in all, it's about 19 lines for the README, which is more than double the actual lines of code for NanoConf itself. And the last thing we're going to do before we push up to GitHub is to create a GitHub directory, and specifically GitHub workflows directory. This is where we're going to define automated actions for our project. And there's going to be two main actions that we're going to be adding in today. One, for pull requests, so that way we can run things like pre-commit as well as our tests themselves. Plus the big thing for this video in particular, which is automating the process of pushing our package up to PyPI. The first file we're going to include is our CodeQL analysis. This isn't going to be something that we're going to write out together because there's a decent amount of information in here. And most of the time you're going to be adding this to your project is going to be based off of some type of template. But I'll go ahead and bring you through this just so you have an understanding of what's going on here. So this on section here is the trigger. And there's two main triggers here. When we push something to the master branch or when something happens to a pull request. So when a pull request is opened, when a change is made, or when a pull request is reopened. Now, if the only contents that have changed in that pull request are a markdown file, so we changed the README, or the git ignore itself, then we're not going to bother running anything. And then here are the actual jobs. All these fall under analyze. We specify the system that it should run on. We specify the container that it should run on, this case being Ubuntu latest, and set up some initial metadata. So when things fail immediately, don't continue on. And this should also make it that way if, say, the 312 job fails, it will cancel the 311 job. Specifying the Python versions also specifies the amount of jobs you're going to run. So when we open a pull request, 2 jobs or 2 actions are going to run the following contents on Python 311 and 312. And here are the actions. So we're going to check out our repository. We're going to initialize and run the CodeQL analysis from GitHub. Then we're going to set up Python itself. We're going to run our pre-commit checks. And finally, we're going to install our project with the dev dependencies, and we're going to run PyTest. So this is what's going to run anytime that someone opens a pull request against this repository. And then the second action that we're going to define is Python publish. This one is fantastic. So similar things that we saw before with the triggers. This is only going to happen when we create a new tag. This is very important, and we'll see how to do this later on. So for this, we're only going to push for the lowest supported version of Python for our project. In this case, that being 311. We perform similar actions that we did before to set up the repository. This time, instead of running tests, we're going to install our project and our setup dependencies. We're going to run the build command itself. Then we're going to use twine to check that the generated files are correct. Finally, we're going to use this action to push our code up to PyPI using a secret PyPI token that we're going to set later. But in order for this to work, we need to define what our setup dependencies are. And we see 2 of them here, which are build and twine. So let's go into our pyproject.toml again. And now we're going to set a new group called setup. In here, we're going to include build, setup tools, and twine. Now, if you didn't want to bother setting up this action, you could absolutely build things locally and then push them up to PyPI yourself. And to do that, you'd run this step here to build the package. You'd use twine to check the package. And then you'd also use twine to upload and push the contents of this dist directory up to PyPI. But that's not what we're going to do today. At this point, we should have everything in place to go ahead, check our git status, add everything in, check pre-commit one last time, then actually make our first commit. That's a whole bunch we could talk about. Commit messages. Initial commits can be a bit iffy though, because you're adding so much in there. So I'm just going to write a basic commit message, especially since everything that I'm doing right now is documented in video form. So if people have specific questions about what's been changed, they can always reference this video later. But for now, this commit message is going to have to do. Okay, so we've added all these files. Just to make sure, we'll go ahead and fetch from origin. There really shouldn't be anything there. We'll rebase against origin/master, which of course doesn't exist yet. And we'll finally push our master branch up to origin. Okay, so everything looks to have pushed correctly. The only thing left for us to do now is to check it out on GitHub. So we still see the initial page we had before, but if we go to our nanoconf directory, we see we have our repository, including our nicely formatted README file. Now, right now, our CodeQL actions are not going to run correctly because we haven't actually enabled CodeQL or code scanning on our repository. So we'll go to security, then code scanning. Then we're going to click the button to configure code scanning tools. And here we're just going to choose the default option and enable CodeQL. So at this point, if we go back to the project, we're already starting to get some analysis running there. If we go to the details for this one, we should be able to rerun the failed jobs. Now, unfortunately for me, even after enabling that under security, I'm still seeing this issue right here. Request error, resource not accessible by integration. And that is even though the actual CodeQL analysis job itself has successfully ran. Now, one thing we can try to fix this is we go into settings, and then actions, general, and then we scroll down to workflow permissions. At this point, let's switch to read and write permissions and click save. Once this is saved, we'll go back to the failing jobs. We'll rerun the failed jobs and see if that fixes it. Now, if you run into this issue where it says that the code scanning could not process the submitted Serif file, there's a good chance this is due to an actual bug within CodeQL itself. At this point, it may be best to go into your settings and disable CodeQL altogether. And now in this action, we'll see that our pre-commit checks are getting set up. They've run successfully. And then our unit tests are also going to happen with the installation of our project, and then PyTest executing as well. So from here, both of our checks should be green and we're good to go. Now let's get a couple things in place so we can trigger the job that publishes our project to PyPI. If you haven't already, create an account for pypi.org. And then once that's done, we're going to go under our account, then account settings. We're going to scroll down in our account to API tokens. In here, you can see two types of tokens that I have. One whose scope is for all my projects, and one whose scope is for a specific project. Now, eventually we want to switch to a specific project scope, as it's not really secure to have one token available for all of your projects. But if you don't have this full token, all you need to do to create it is click Add API Token. At this point, you can call it whatever you want. We'll call this one temp full, and we'll enable it for our entire account. Later, after your project has been pushed to PyPI, you'll also see that project scope down below. So at that time, go ahead, create a new token for your project, and then you're going to copy that and add it to your repository secrets like we're going to do with this token right now. Now that we have a full token, let's go back to our repository in GitHub. In the repository, remember that under workflows and Python publish, we want this to be stored under secrets, and that's going to be PyPI underscore token. So in our settings, we're going to go to secrets and variables, then actions. Now we want to create a new repository secret, and this is going to be PyPI underscore token. And then you paste in your secret here and then click add. And now you have a repository secret, which is the PyPI token, which can be used in your workflows. And then finally, to push a new release of your package to PyPI, we're going to go over here to releases and then create a new release. We're going to select tag. You can start this with any version that you want. If it's a brand new project, it can be any semantic version like 0.0.1, or if you're bold, 1.0.0, and then select create new tag. One really nice thing I like about GitHub is that you can also generate release notes. Now, unfortunately with this, because there was no previous release, it's not going to have anything to give a diff between. But when you are generating multiple releases, it'll give you a good changelog of the pull requests that have happened between versions. So we'll give this a new title, and we'll give our release a quick description. Okay, and when you're ready, hit publish release. Okay, we now have a new release formed, which means if we go to the nanoconf repository, and then under actions, we should see our Python publish action trigger. Now, unfortunately for me, it looks like what I was fearing earlier is actually true. We got an error saying that our classifier for the license custom is not a valid classifier. But this gives us an option to also try a new pull request. So we'll go back to our repository, into our pyproject.toml, and this time let's try leaving the license out entirely. Let's create a new branch by running git checkout -B, which is going to create a new branch, and we'll call this branch fixed license. We'll add our changes. Nothing should really trigger in pre-commit, so we're good to go, and we'll create a new commit. Now that we have our commit, we'll push up to origin, and that will be our fixed license branch. Back on our repository, we see that fixed license has a recent change, so we'll click compare and pull request. We'll look at the changes, looks correct, and we'll create our pull request. And if you look at this, once our pull request has been submitted, and if we have the correct permissions for this repository, which being the owners we do, our GitHub actions will automatically trigger, and once they're done, should report their status positively or negatively either way. Perfect, our checks have completed, so now all we need to do is merge the pull request. And we'll go ahead and delete the branch. Okay, back on the repository itself. We drafted this release, but it didn't get uploaded to PyPI, so it doesn't really count yet. What we can do in these cases is delete the release, and we can also delete the tag. Hopefully this isn't something you have to do often, and if you have a larger repository with a lot of people active on it, this may cause issues with them. But in our case, it's just us, so we can try again. And this time, since we do have a PR that's been merged, we get some new output here. So when we publish it, this is what it's going to look like. Let's go ahead and publish the release. Okay, it's published again, and hopefully this time, removing that line from the package build will allow us to push up to PyPI. Okay, here we go. The upload completed. And now it says view at pypi.org, project nanoconf, and we have our project up on PyPI. And look at that, our README is rendering correctly. We see our classifiers on the left here that we specified, as well as some of our other metadata, including a link to our repository itself. Perfect. To prove that this is live, not only can you install this yourself right now, but I'll delete the virtual environment that I have here, create a new one, and then I'll pip install nanoconf. And here we have it, for the very first time, a nanoconf installation. So of course, if I could spell IPython correctly, we could say from nanoconf import, this time will be proper, nanoconf. And that's where we'll leave it for today. If you made it this far, thank you so much for bearing with me through this very long video. If you learned something new and haven't already subscribed, please consider subscribing. And also, if you use this video to create your own packages on PyPI, please feel free to link it in the comments below with the description of what it does. Let everyone know what you're up to. My name is Jake, and thank you for watching.